Okay, so we will discuss this complex number question from the October-November 2008 paper. Okay, it is from winter session at winter 2008, and the complex number question is question number 10. All right, so here they give us a complex number w, which is given by this coordinate. All right, so negative half plus square root 3 over 2i. They want us to find the modulus and also the argument of w. All right, so to find out the modulus and argument, so this question is actually quite straightforward. Okay, so the modulus of w, it will be x squared for the complex number plus the y squared, the real part, the coefficient of the imaginary part, sorry, for the complex number. And you have 1 over 4 plus 3 over 4, which is equals to square root 1, and the modulus of w should be equals to 1. And now we are going to look for the argument w. Okay, so for argument w, it will be tangent inverse. Okay, we are having y over x, so square root 3 over 2 divided by 1 over 2. All right, so I would like to figure out which quadrant this complex number belongs to. Okay, so if let's say you roughly draw and you have a look for the value, you're having negative half plus square root 3 over 2. So that means the w should be somewhere here in the second quadrant. All right, so for actually the answer in the second quadrant, if you want to get the argument, what I will do is that I will take pi minus the tangent inverse of square root 3 over 2 divided by 1 over 2, which means I try to find out the basic angle for the w first, the basic angle which is in the first quadrant, and after that to get a respective, okay, the aligned angle in the second quadrant, then I have to take pi minus the basic angle. All right, so from this case, you have pi minus pi over 3. So the pi over 3 will be the basic angle, and therefore the answer that I get straight away will be 2 pi over 3. So this is the argument for the w. All right, so you might have some other methods to find out the 2 pi over 3. As long as you get a correct answer, then it's okay. All right, so for me, I'm using the basic concept method. That means I ignore the negative when I find out the basic angle. Then after that, because I know that it is from second quadrant, therefore I use pi minus the basic angle to get the answer for the argument. All right, so this is what we have for part number 1. Okay, then now we continue to part 2. Okay, so for part 2, they are telling us that the complex number z has modulus r and argument theta. So the r and theta, so far we still not yet know, okay, what is it? But we know that the theta is from negative pi over 3 until positive pi over 3. So that means this theta can be from negative 60 degree until positive 60 degree. And they actually want us to state the modulus and argument of wz and also the modulus and argument of zw. All right, so for this question, generally from the first sentence given, we actually can write out some important information, which is the modulus z is equals to r and the argument of z will be equals to theta. All right, so this is the information that I get from this sentence, and after that they ask us to state the modulus and argument of wz and also the z over w. All right, so by using the property that we learned, the modulus of wz is actually equals to modulus w multiplied with modulus z. Right, so modulus w already get it in first part, which is a 1 multiplied with r. Therefore, the modulus of wz will be r. Okay, then the same thing happen, we will apply for argument. So we are having argument wz. So for the argument part, it will be actually equals to argument w plus argument z. So argument w will be 2 pi over 3. Then the argument z is actually a theta. All right. Okay, or you can write as theta plus 2 pi over 3 also can. Just that the theta, the value is between negative pi over 3 until positive pi over 3. All right, so for this one, this is the answer for argument Wz. Okay, so next, modulus and argument for Z over W. Okay, so the next one will be Z over W. To get the modulus, it will be modulus Z divided by the modulus W. Okay, again, modulus Z that we get is actually a R, and then the modulus W is a 1. So the final answer for this modulus will be the R. Okay, so the last one, which is the argument Z over W. So for divided, the formula will be argument Z minus argument W. Okay, so again, for modulus Z, what we can see is the modulus Z is theta minus the argument W, argument Z will be theta, and the argument W will be 2 pi over 3, like what we count just now. Okay, so here we shown the 4 different answers, okay, for the modulus and argument of WZ and also Z divided by W. So this is how we actually solve part number 2. All right, okay, then next, let us continue to the, okay, so for part number 3, they want us to use the result in 1 and 2 and explain why the points representing Z, W, Z, and Z over W are the vertices of an equilateral triangle. Okay, so maybe at first we need to try and see whether we're able to plot it out in the Argand diagram or not. Okay, so maybe I will draw the axis here. All right, so let's have a look with the Z first. So the Z modulus Z is R, and then the argument Z is theta. Both values here, both answer the number here that we don't know. We only know it should be a number, but they didn't give us what is the exact number. All right. So the argument is theta. The modulus is R. But for the argument part, they actually tell us the theta is from negative pi over 3 until positive pi over 3. Okay, so theta can be any number between all these. Then to make my drawing easier, I will assume that the theta is equals to 0, which is in the center of negative pi over 3 until pi over 3. And when the theta is equals to 0 also, later it will be easier for us to sketch out the graph. Okay, all right, so when theta equals to 0 and the modulus Z is equals to R, that means for my Z, okay, I assume that R is this length. So theta equals to 0 means that it will be on the x-axis. Okay, so this is the point Z, and I will represent it by using a letter A. Okay, all right, so I assume that this length is the length is R, and then I assume that the theta is 0, so that later when I want to calculate or when I want to draw any other things, it will be easier. Okay, then for the next point, we are going to sketch WZ. So for WZ again, if you look at the modulus, the value is still R. So that means later when you want to sketch the length, okay, for WZ, it should be the same length as this one. And then for now, we look at the argument. So argument WZ will be theta plus 2 pi over 3. Because we assume that our theta is 0, right? So it will be 0 plus 2 pi over 3, which means that the argument for WZ is 2 pi over 3. So 2 pi over 3 means 120 degrees from the positive x-axis. So it might appear somewhere here. And then when I sketch, I try to sketch the length here, the green color part, same as the purple color part. And for this particular point, I will label it as WZ, or I maybe can name it as a B, a point B. And then you have to know that this is 2 pi over 3. It is plus 2 pi over 3. Okay, or theta plus 2 pi over 3, but because of theta is 0, so when I draw, I assume that theta is 0, so I'm having a 2 pi over 3 here. Okay, which is 120 degrees. Okay, all right, and then now we go for the third point. So the third point here will be Z over W. Again, the modulus is equal to R, and then the argument. Okay, the argument is theta minus 2 pi over 3. So if you assume that theta is 0, then minus 2 pi over 3. The argument for this point will be negative 2 pi over 3. So negative 2 pi over 3 means what? Means that you need to draw it in clockwise direction for 2 pi over 3, which is negative 120 degree. So you can assume that it will be here. This is negative 2 pi over 3 lah. Okay, but originally it should be theta minus 2 pi over 3, just that we assume theta is equal to 0 at this case. All right. Okay, so now for this point, I will make it as Z over W, or I will label it as C. Okay, so to make the explanation easier later, then maybe I will make this center as a 0. Okay, all right. So once I sketch it out in the Argand diagram, okay, by assuming the theta is equals to 0, so this is something that you can see. And they actually want you to explain why the point A, point B, and point C okay, actually form the equilateral triangle. So they want you to explain. Okay, all right. So now, maybe before we can explain it, we have a look for the property of the equilateral triangle. Let's say this is one of the equilateral triangle that we have. Okay, then equilateral triangle means that all the sides are the same, right? All the sides are the same. Okay, and another thing is you need to know all the angle here will be 60 degree. So this one 60 degree. The whole angle here also 60 degree, and this angle also 60 degree. Okay, then another property for the equilateral triangle is when you try to draw the altitude from a point, okay, from each point, I can say from each vertices, you draw the altitude, then this one also draw the altitude, this one you also draw the altitude. You can see that all of them actually intersect at one point here in the center. Okay, so the length from the vertices to the center is always the same. Okay, so this is one of the property for the equilateral triangle that we need to know at first. Okay, all right, so you can see that if let's say we are having the equilateral triangle, from the vertices to the center, right, all the length are the same. Sorry, this one I cancel. Okay, so all the length are the same in black color one. All right, so you can see from here, in our case, right, it is very similar to what we have here. Let's say this is O. So you can see that from O to the vertices A, from O to the vertices B from O to the vertices C. It is all with the modulus R, which is having the same length. So it fulfills one of the property for the equilateral triangle. Okay, so next one. Next one to prove is this small angle here. The green color one is 30 degree, right? Because 60 degree divided by 2 equally. So it will be equal to 30. So the same thing happened for this part. This is equals to 30 as well for the green color part. Okay. And now, what is this angle itself? Okay, so for one small triangle, okay, maybe I emphasize it by using this black color lah. So by looking at this black color small triangle here, you know that they are isosceles triangle, right? And then both angle at the side is 30 and 30. Therefore, you should know that this angle in the center, it should be 120 degree. So you should know that 120 degree also equals to pi over 3. Oh, sorry, 2 pi over 3. Can I erase it? 2 pi over 3. Okay, then same thing happen for this one. Should be 2 pi over 3 as well. And for this angle is also 2 pi over 3. All right, so again, we want to compare it with our Argand diagram. So from here, you can see that this angle, Okay, is 0, sorry, is theta plus 2 pi over 3, which is 0 plus 2 pi over 3. So this is 2 pi over 3. No? Then the bottom one, blue color one, also 2 pi over 3. And if you try to calculate, right, 360 degree minus 120 minus another 120, you also get 2 pi over 3 here, which means that it fulfills the second property for an equilateral triangle. All right, so from here, actually, we can prove that, okay, the vertices, the points that we draw in the Argand diagram is actually a equilateral triangle. All right, but of course, before you prove, you need to have the idea that the property of the equilateral triangle should be something like this. Okay, all right. Yeah, so hopefully you can see the pattern, then you compare. All right, so to make it as a conclusion in our solution, okay, wait. Okay, so maybe I try to move this over. Okay. All right, so to make it as a conclusion, right, what we can write is something like this. First, we talk about the length. All right, OA is equals to OB is equals to OC, which is equals to R. All right, so that means the length from center to vertices are all the same. Okay, so the second property is about the angle. So angle AOB equals to angle BOC equals to angle COA or AOC. They are all 120 degree. So all these actually fulfill the equilateral triangle. Okay, so you can say that so Z, WZ, and also Z over W, okay, are the vertices of an equilateral triangle. Okay, so for this case, right, I tried to write out two properties now. It is because of when I look at it, I realized that there are 2 marks given. So I think to be on the safe side, you should write out two properties to show that it actually fulfills the property of the equilateral triangle. All right, so this is what we have here for part number 3. Okay, all right, so next is part number 4. Okay, so for part number 4, again, they are telling you that in an Argand diagram, the vertices of an equilateral triangle lie on a circle with the center at the origin. Okay, so here they already tell you that center at the origin, and all the vertices lie on the circle. Okay, one of the vertices represents the complex number 4 plus 2i. Find the complex numbers represented by the other two vertices. Give your answer in the form x plus I, y, where x and y are real and exact. So I think you need to highlight the word exact. Okay. All right, so now we actually need to try to link part number 4 with part number 3 here. Okay. So you can see that just now they already tell you that we are having an equilateral triangle in part number 3, right? And this triangle actually lies on a circle, and the 0, the O is the center. So like you now can imagine, actually from our part 3, okay, all the 3 points here lies on the circumference of a circle. So it might look something like this. Okay, because I'm not drawing a proper, according to the proper ratio, so you can see that the circle is a bit weird. Okay, but generally it will look something like this. Okay, and then they tell you that one of the vertices represent the complex number 4 plus 2i. Okay, so they are telling you that for these 3 points, right, one of the point is actually 4 plus 2i. We are having 3 points here also in our graph, z, wz, z over w. Okay, z should be a complex number, but too bad just now I don't know what is the value. All right, so I assume that it is with argument 0. But now they already give us a complex number 4 plus 2i. So that means the 4 plus 2i can be one of the points here. It can be this one, it can be this one, it can be this one. All right. So they actually want us to find out the vertices for the coordinate for another two vertices. So that means for me, right, I will let the z equals to 4 plus 2i. Once I let z equals to 4 plus 2i, then I can find out the other complex number very easily, which is you can take w multiplied with z, and also you can take z divided by w. You already have the w, right? The complex number w. You don't have the complex number z. So for now, if I assume that z is 4 plus 2i, then very easily, besides the first point here, the first vertices here, you can get the complex number for another two vertices easily. Okay, so that's why for this part, we will actually let z equals to 4 plus 2i. So z equals to 4 plus 2i is one of the vertices of the equilateral triangle. So another point, another complex number for that equilateral triangle will be wz. Okay, or zw also can. So what is your w? Negative half plus square root 3 over 2i. This is given at the very beginning of the question. And now I'm having 4 plus 2i. Okay, so I try to expand. Okay, so negative 2 multiply with this one, what do you get? You get negative 2. Okay, then negative half multiply with this, then you will get negative I, right? Okay, then the same thing happen for the second term, this one, and also this. Then you should get plus square root 3i. 2 square root 3i. Okay, so you have 2 square root 3i. And also the last term, it will be negative square root 3. Okay, so you try to group the real part with real part, imaginary part with imaginary part, and therefore you are having negative 2 minus square root 3 plus 2 square root 3 minus 1 i. So this is the other complex number for the second vertices for the equilateral triangle. And this is in exact form, that means it is in the third form. Okay, and after that, to get another complex number for the third point, okay, according to what we showed in part 1, 2, and 3, it will be z over w. Okay, so again, z is 4 plus 2i. W is negative half plus square root 3 over 2i. Okay, so for this part, maybe you need to be a little bit more careful. Okay, you need to rationalize it. Right, so how to rationalize it? Okay, let me write it out first. Okay, so to rationalize it, you need to multiply, right? So multiply what? Multiply negative half minus square root 3 over 2i. This one also the same, negative half minus square root 3 over 2i. Okay, so you need to be extra careful when you want to expand everything here. Okay, so you are treating it like this also. You have two brackets at the bottom. So first term multiply with first term multiply with second term, and you do the same thing for the second term here. Okay, also the same thing for the number on top. Okay, the numerator. All right. Okay, so if you didn't do any careless mistake, right? Okay, for the denominator, eventually you should get 1 over 4 plus 3 over 4. And then for the numerator on top, this should be what you get. Okay, after that, again, try to rephrase your answer. Okay, try to rephrase it. The real part with the real part, imaginary part with imaginary part. Okay, and you can see that this whole thing is equals to 1. Right, so you only have numerator. So for the numerator part, if you didn't do any careless mistake, then you have square root 3 minus 2 for the real part, then minus negative 2 over 2 square root 3, sorry, should be plus. So it should be 2 square root 3 plus 1 i. Okay, so this is actually another coordinate, the complex number lah. I can say it is another complex number for the third point of the vertices on the equilateral triangle. All right. So for this question, generally what I do is like for part number 3, okay, before you can prove that it is the equilateral triangle, you need to know the property of equilateral triangle first. And once you draw it on the Argand diagram, right, by assuming that the theta is equals to 0. So again, I assume theta equals to 0 so that for the drawing part and also the calculation part, it makes me much more easier. Okay, it makes the steps easier. So you can see that actually I'm having something like this. Then from here, you can prove that it is actually the equilateral triangle. After that, for part number 4, they already tell you that one of the point, okay, of the equilateral triangle is 4 plus 2i, the vertices. So you can straight away assume that z is equals to 4 plus 2i. Then from there, you can find the coordinate of wz and also z over w in the very straightforward way. Just that you need to expand the complex number and rationalize it. So these two will be the exact complex number for the other two vertices of the equilateral triangle. Okay, so now let us discuss a complex number question from summer 2013, which is May-June 2013, paper 3-1. Okay, so we take out the question number 7, which related to complex number. Okay, so without using a calculator, solve this equation, and they already tell you that W star denotes the complex conjugate of W, and give your answer in the form of A plus BI. Okay, so for this question, I will actually assume that the W, okay, this is actually my W. All right, therefore, W star will be A minus BI. So I try to substitute the A plus BI and also A minus BI into this equation. Then from there, I try to compare the imaginary part and the real part. Then I can solve simultaneous equation to get the value for A and B. So this is what I plan to do. Okay, so I copy the equation first. All right, so 3 and then W is A plus BI plus 2i, then W star it will be A minus BI, the W conjugate, and it is equals to 17 plus 8i. Okay, so I try to expand everything. Okay, all right, so what I'm going to do now is I try to group all the real part together and all the imaginary part together from the left hand side. So the real part will be 3a plus 2b. And the imaginary part will be 2a plus 3b I, and it is equals to 17 plus 8i. All right, okay, so from this step, I will want to compare for the left hand side real part, compare with the real part on the on the right. Okay, so from here you can find first equation 3a plus 2b, it is equals to 17. And after that, for imaginary part, you can form another equation. So for imaginary part, this is the imaginary part on the left. You compare it with the imaginary part on the right hand side. So you will have another equation, which is 2a plus 3b equals to 8. Okay, so you try to solve simultaneous equation from the equation 1 and 2. All right, so what I do here is I take equation number 1, multiply with 2, minus equation number 2, multiply with 3. Okay, all right, so from here, I will get negative 5b equals to 10, and therefore b is equals to negative 2. And after that, if I continue to find the a, okay, by substituting the b equals to negative 2 into either first or second equation, all right, then of course a, I will get a 7. So from here, very easily, I will get the complex number w, which is w equals to 7 minus 2i. Okay, so this is the answer for part number 1. And of course, when you solve simultaneous equation, right, you can use your own method. As long as you solve it without doing any careless mistake, then this is the answer that you will get. All right, then let us proceed to part B. Okay, so this is what you have for part B. All right, so for part B, you can see that they tell us in an Argand diagram, this is the locus that we have, loci, intersect at point P. So we have two loci here. This is the first one, and this is the second one. And they tell you that they intersect at the point P. Okay, so express the complex number represented by P in this form. So R equals RE I theta. So again, just to recall back, what is the meaning of the I? I means the modulus of P. And the theta here will be the argument of P. Okay, giving the exact value of theta. So again, I think for theta, you need to highlight the word exact. Okay, and the value of R correct to three significant figures. All right, so this is what we have. So I think the first step is we need to sketch out the two loci here. Okay, so before I sketch the two loci, what I need to do is that I want to see which point should I start from. Okay, so this is z minus 2i. So to sketch it on the Argand diagram, I'll rephrase it become z minus 0 plus 2i equals to pi over 6. So this actually tells you that later when we want to sketch the Argand diagram, right, the point that we are referring to should be 0, 2. 0 means the real axis, 2 means the imaginary axis. Okay? All right, so maybe I can try to label it first. Okay, let's say, I assume that this is 1, this is 2. Later this is 3. Okay, so we have 1, 2, and 3. So when they mention that z minus 0 plus 2i equals to pi over 6, so the 2, 0, 2, it will be at this point. Okay, so this is the point 0, 2 lah. Okay, imaginary axis, and then the real axis. Okay, and then when you want to sketch the argument pi over 6, you imagine that you have a horizontal line on the right hand side of the point. Okay, and it is pi over 6. So pi over 6 means 30 degrees, which is quite low. So maybe this is my line. Then you just label this as pi over 6. Okay, so this is my first locus at this line. Okay, then now we continue with the second locus. So I'm having modulus z minus 3 equals to modulus z minus 3i. So again, I usually will replace it. It will become z minus 3 plus 0i. Okay, then equals to modulus z minus 0 plus 3i. So from here, you can see that we are having the point 3, 0 and also 0i, 0, 3, sorry. Okay, 3, 0 and 0, 3. All right, so therefore, for this locus, it is actually the perpendicular bisector for 3, 0 and 0, 3. Okay, so you should know that this is 3, 0, this is 0, 3. Okay, so if I draw a very light line here, okay, it is the perpendicular bisector. So perpendicular bisector means that the midpoint between 3 and 3 here, so I roughly sketch. So I assume that this is the midpoint. Okay, so perpendicular bisector means that it will be divided at 90 degrees. Okay, so going up also. Okay, where this is 90 degrees. All right, okay, and then this is the locus, the second locus, this one. Okay, it is actually the perpendicular bisector between 0, 3 and 3, 0. All right, okay, so once we're done sketching this part, then now let's have a look. Where is the P? So P is the intersection between these two locus. Okay, so that means this is actually the P. Okay, so to find out the modulus of P and also the argument of P, okay, you need to try to link the Argand diagram with some shapes, geometrical shapes, okay, or polygon. All right. So the Argand diagram actually will provide you some useful information. So as an example, like for this one, okay, the modulus of P means that the length for this line. This line is the modulus of P. Okay. All right. So to find out this length, what am I going to do is maybe I will want to use this triangle. Okay, so you can see that your Argand diagram actually there's some useful information in your Argand diagram. So maybe to find this length, I'm going to refer to this triangle. Okay, right. So to refer to this triangle, right, I know that this length, this side, is actually a 2 unit, which is quite straightforward, right? Okay, then now let's have a look for this angle. Okay, this angle here. So it will be 90 degree plus 30 degree. Pi over 6 is 30, right? So 90 degree is pi over 2, then plus 30 degree, which is 1 over 6. So this whole angle here, the whole thing here, okay, this whole angle in green color will be 2 pi over 3. Okay, all right. Then now, let us have a look for this. Actually, I will know that this is the pi over 4. Why is this pi over 4? It is because from the original triangle here, this one, 3 unit at the bottom, 3 unit is the height, right? So it is actually the not to say equilateral, the isosceles triangle, right angle triangle. So that means this is 90 degree. Oh, sorry, 45 degree. Okay, so when you're having 90 degree here, and this is the perpendicular bisector of this 45 degree, therefore it is also a 45 degree. So that means I can conclude also this smaller triangle inside, okay, also 45 degrees. So that 45 plus 45 degree, it is equals to 90 degree. Okay, so you already have these two angles for this triangle. Therefore, it is not hard for us to find out this one. This one will be pi minus 2 pi over 3 minus pi over 4. Okay, so pi minus 2 pi over 3 minus pi over 4, you will get pi over 12. Okay, so if you look at this triangle one more time, you already have the angle for 3 inside this triangle, and also you have one length, okay, for the side. So to find out the P, the modulus of P, you can use some rules that is related to the triangle, related to cosine rule or sine rule to get the answer. So maybe for this case, I'm going to use the sine rules. So sine rules means the length over the sine of the opposite angle. So that means I'm using the length 2. Where should I write? Should I write here? So 2. Okay, 2 is this one, right? The opposite angle is pi over 12. So 2 divided by sine pi over 12. The ratio is equals to the modulus P. So this is modulus P. The opposite angle will be 2 pi over 3. So divided by sine 2 pi over 3. Okay, so I think from this equation, you will be able to get the value for modulus P very easily. Okay, by just pressing the calculator. Okay, so if you try to press calculator, this one you will get a long value, okay, which is actually 6 point. Wait, let me calculate it out. So it will be around the value like 6.69213043. Okay, and of course you need to change it become 3 significant figure, so it will be 6.69. So this is actually the modulus of P, which is also the R. Okay, so this is also the R. Huh? All right. Okay, so once we use this triangle already, then now we are looking for the argument of P. So I think argument of P is very straightforward because you already know that this is the line of P, the point of P, and then when you connect the point of P to the origin, right? So the angle, okay, this angle will be actually the argument of P. So very easily, okay, without any steps, you can straight away get the argument of P from the diagram, which is pi over 4. And you should keep it in the exact form. So I'll keep it as pi over 4. All right, then again, they want you to rewrite the P into the form, exponential form. So P equals to 6.69, and then E I theta. So the theta will be pi over 4. So this is a final form that they want us to express P, which is in exponential form for a complex number. All right, so you can see that for answering this kind of question, generally I will always look for Argand diagram, and then we will try to use some basic shapes, okay, to help us to answer the question. So like for this example, we are using the triangle that already been formed in the argument, in the Argand diagram, and then by using the information of the Argand diagram that you have, such as the angle, the length, okay, we try to relate it with the shapes to get the answer that we want. All right, and of course, this is not the only answer. Some other methods will be you can form the equation for the perpendicular bisector, then you try to solve simultaneous equation. Okay, also can. All right, but to me, by using the shapes that appear in the Argand diagram, usually will be much more straightforward and much more easier to get the answer that we want. All right, so this is what we have for this question, the complex number question from May-June 2013, paper 3-1. Okay, so now we discuss on this question, okay, from May-June 2012, or the summer 12 session, paper 3-3, and question number 10. Okay, so this complex number, they give us two complex number here, W and U, that satisfy this equation. And they want us to solve the equation for W and U, giving all the answer in the form of x plus yi, where the x and y are real. Okay, so for this question, very simple. What we do is we try to solve simultaneous equation. So that means that when we are having U minus W plus 4i equals to 4i, so I can let U equals to 4i plus W. And this is my first equation. All right. UW equals to 5. This is my second equation. Okay, then from here I can solve simultaneous equation. So I will substitute equation number 1 into equation number 2. All right, so U is 4i plus W multiplied with W, and it is equals to 5. Okay, so from here, what will I get is I will get a W. Okay, W 4iw plus W squared equals to 5. Okay, then again, if I rephrase everything, then I'm having W squared plus 4iw minus 5 equals to 0. Okay, so from here, if you want to continue, there are a few ways for you to do it. The first one is you can see that this is a quadratic form equation in terms of W, right? Okay, so what are we going to do here is we can try to use the quadratic equation for W, quadratic equation for W, so which is negative B plus minus B squared. So B squared minus 4AC, then divided by 2A. Right, so you continue further. Okay, so negative 4i plus minus 4 squared is a 16, I squared is negative 1, so you have negative 16. All right, then for negative 4 minus 5, you have 20. Then divided by 2. So you have you have negative 4i plus minus square root 4 divided by 2. Then if you continue from here, you have negative 4i plus minus 2 divided by 2. So that means if you look at the answer here, generally you have two set of answer. The first one will be negative 4i plus 2 divided by 2. Another answer will be negative 4i minus 2 divided by 2. And of course, you can try to simplify it. I will have 1 minus 2i and also negative 1 minus 2i. Alright, so you can see that for our w, we will have two different values here, which is 1 minus 2i and also negative 1 minus 2i. Okay, alright. Once you have the value of w already, then of course you can find the value for u. Okay, so to find the value of u, you can use back the easier equation will be the equation number 1. Okay, so I will let okay, so u equals to 4i plus w, right? So it will be 1 minus 2i. Another set of answer will be 4i plus negative 1 minus 2i. So what is your value of u here? It will be 1 plus 2i. And another one will be negative 1 plus 2i. Okay, so this is your value for the equation for, the answer for u, which is a complex number. Okay, so if you want it to be safe, then you can write it like this: when w equals to 1 minus 2i, then u is 1 plus 2i. They are in one set, right? Okay, so when w equals to negative 1 minus 2i, then you can write as u equals to negative 1 plus 2i. Because they come in pairs, so usually I will want to rewrite it in pair. Okay, so we know that when w equals to this value, then u should be this answer, and so on. All right, so this is how we solve it. Okay, for question number 10, part A. So you can see that I'm using the quadratic form equation here to solve. Okay, the quadratic equation, the quadratic formula to solve the quadratic equation. So this is one way. Another way will be slightly longer, where you let w equals to a plus bi. You expand everything, you group the real number to one side, all the imaginary part to one side, and then you compare. You also can get the answer from there, just that the steps will be slightly longer. Okay, so to me, I think this is shorter. All right. Okay, so this is the suggestion where you can use this quadratic formula to get the answer. Okay, so this is what we have for part number A. Let's continue to part B. Okay, so for part B, part 1, on the sketch of an Argand diagram, they want you to shape the region, okay, whose point represent the complex number satisfying the inequality. So how many inequality we have here? This is the first one, first inequality. This is the second inequality, and this is the third inequality. Okay, so where the REZ means that the real part of Z. And after that, they want you to calculate the greatest possible value of real part of Z for the points lying in the shaded region. So maybe we start with the first part first. Okay, so first of all, again, first inequality that I have is modulus Z minus 2 plus 2i smaller equals to 2. What I want to do is I want to rephrase it first, become Z minus bracket 2 minus 2i. So that means later this 2 and negative 2 will be the center of the circle that I want to draw. Okay, and this whole locus is actually a circle, right? Then after that only I shade the region due to according to the smaller equals to 2. Okay, so the center here will be very obvious, which is 2 and negative 2. Okay, the second locus is argument z. Okay, smaller equals to negative 1 over 4, right? If I rephrase it, it will become z minus 0 plus 0i. Smaller equals to negative 1 over 4 pi. So that means later when I want to draw the angle, this argument for negative pi over 4, right? Okay, I'm going to refer to the point 0, 0. Okay, 0, 0 will be the point, and then start from there. I will try to sketch, okay, the locus with the argument negative pi over 4. Next one is REZ, real part of z greater than 1. Okay, usually on x coordinate, right? Sorry, the graph, we are having the x-axis, y-axis, or real axis, or imaginary axis. The real part in the Argand diagram is actually the x, the horizontal axis. So when they say real part of z greater than 1, it means that x is greater than 1. All right, so once we have the idea how to do all this already, then we can start sketching our graph. Okay, so maybe for the first locus, what I want to sketch is the circle. Okay, so at first, maybe you can decide the scale that you want to use, the ratio that you want to use. Okay, so I assume that this is what I have on negative. This is real, this is imaginary. Okay, so from the first inequality here, you can see that the center is 2 and negative 2, and then the radius is 2. So center is 2 and negative 2. It should be somewhere here. And the radius 2 means that you pass through this point, this point, this point, and this point. Okay, so I just roughly sketch it out and try to make sure that your circle looks like a circle. Okay, all right, so this is my first one. Okay, and then if they want you to shade the area smaller equals than 2, that means originally you have to shade the whole circle inside. All right, okay, then now we proceed to the second part. Modulus, argument z smaller than negative 1 over 4 pi. Okay, so 0, 0 is here. Okay, then from the right hand side, from the x-axis, you try to measure pi over 4. Okay, in clockwise direction because of the negative sign. So that means when you want to sketch the angle, it should be in clockwise direction. So that means you measure 45 degrees down from the x-axis. Okay, and then you know that this is the line and it will pass through all the value or all the points with the same value of x and y. As an example, like this point is 2 and negative 2, right? So you pass through the 2 and negative 2. So this line also pass through 1 and negative 1, 3 and negative 3, 4 and negative 4. Okay, why? Because of the angle here is actually pi over 4, 45 degrees. Okay, so all these are some small details about the triangle, the property of triangle, and also the angle that we need to know when you want to sketch all this. Okay, and after that, they are saying that we want to sketch for this inequality smaller than negative pi over 4. Okay, so the angle from here until here is from negative pi over 4 until 0. Okay, so from here until this part, this whole area, okay, the argument is actually negative pi until negative pi over 4. So very obvious, if they want us to sketch this one, we should shade this area. Because this area is, the argument is more than negative pi over 4. This area, the argument is less than negative pi over 4. Okay, so according to this inequality, I should shade this area. Okay, so combined with what we have just now you shade it inside the circle, and now you want to also shading this area, so the overlapping part will be this part, the overlapping part, right? Okay, so far for now we have this overlapping part here. Okay, all right, so this is what we have for the second inequality. Okay, then before we can shade the final answer for the shaded region, we need to continue with the third inequality. Okay, so please wait me for a moment. All right, so you already know, okay, so this is the so far what we have for this area. Okay, then after that, they are having x greater equals to 1. So that means you sketch the line x equals to 1. When we are having x equals to 1, that means it is actually a vertical line. Okay, vertical line at x equals to 1. All right, so this line is actually x equals to 1. And they want you to shade the area more than 1 or more than equals to 1. So by combining the three inequality that we have here, just now is the whole circle for the first one. After that, you focus on this part, but the overlapping will be below the lower part of the circle. And now they want to have x greater than 1, so that means this part. Okay, so if I shade it in detail, so this is the shaded region that we should have. Okay, all right. And of course, don't forget that just now you have this angle here in the second inequality, right? So this particular angle is pi over 4. We no need to shade it. I just want to let you know that this is actually pi over 4. Okay, so here, this is the Argand diagram that fulfill all the three inequality. Okay, and the shaded region is somewhere here. Okay, all right. Then now again, when we go to part number 2, they want us to use to find out the greatest possible value of real z for the points lying in the shaded region. So shaded region is this one. Greatest possible value of real z means that the greatest possible value for x. Okay, for the point that lies in the shaded region. So you can see that if you go to the left hand side, the value of x is smaller. If you go towards the right hand side, then the value for z is greater, right? So the largest value of x in the Argand diagram will be this one. Because this is the last point lying in the shaded region with the largest value of x. Because if you move further to the right hand side, there's no more shaded region. All right, so this is the value that we want to find. Okay, so how to find out this value generally? We actually don't know what is the point for this point. What is the coordinate for this point? Okay, so what we can do now is maybe we can try. Okay, so we can try to have a look for some useful shapes that can help us. All right, so to find out this value, sorry, they want us to find the greatest value of x, right? Oh, so that means we want to find this value, the x value. Okay, my Argand diagram is not good enough, so that's why you see that the arrow is like pointing to the tree, but actually it is not the tree. Okay, right. So actually we want to find this value. Sorry, this whole thing here. This is the value of x. So to find this value of x, right, I will use the help of this green color triangle to help me to get the side. Okay, all right. So again, maybe here I just want to show you that the answer that I want to get is this length. Okay, and I'm referring to this triangle. Okay, so this is a right angle triangle. Okay, the angle, this one in green color that I highlight now, is pi over 4, 45 degree. So automatically you should know that this is also pi over 4. Okay, and because this is 90 degree, that's why you should know that this value, if let's say I assume that it is A, the x value is also the A, because they are 45 degree, right? So the base and the height should be at the same length. All right, so again, all these are something basic that we need to know. All right, okay, so these two triangles should have the same length, the side here. Okay, then let's have a look for the hypotenuse. Okay, so for hypotenuse, right? What is the length for the hypotenuse? Okay, so again, you might need to use some small knowledge that we learned before. If you look at this triangle, right, the hypotenuse, okay, the hypotenuse length will be actually equals to what? The square root of, okay, so now, this length until the center plus the radius, okay? So this length, this is the length for 2, the point 2 and negative 2, right? The center is 2 and negative 2 ma. So 2 and negative 2 will be 2 square plus negative 2 square. Okay, so you are actually finding the length between the origin with the center. So, or you can write like this, 2 minus 0 square plus negative 2 minus 0 square. Okay, and after that, you want to add this part. So this part is actually radius of the circle, so which is plus 2. Okay, so again, the hypotenuse length is built from the length from 0 until the center of the circle. So this is the length from 0 until the center of the circle plus the radius of the circle. Okay, so that's the hypotenuse length. So from here, if I continue, I will get square root 8 plus 2. Okay, then now, once I get the hypotenuse length already, if I want to get the side length, okay, so again, I'm using the triangle here. The side length will be what? Side length is a, right? So you should know that a square plus a square is equals to the hypotenuse length square. Okay, and then from here you are seeing 2a square equals to square root 8 plus 2 square. Okay, then by using calculator, okay, so by just using the calculator, what you will get is you try to expand everything and replace everything and take square root. Okay, so your a should be 3.41, or if you are using some other calculator, then the answer that they give you will be 2 plus square root 2. Okay, so we can double check again and see, did they ask us to write out the answer in exact form? So here they only mention that calculate the greatest possible value of real x, real z for the points lying in the shaded region. So generally they will accept any of the answer here, either in the third form, okay, or either in the decimal form. So it will be 3 significant figure, which is 3.41. Okay, so again, for this question, right, to answer the length, to answer the question, again, you can see that we are trying to use the triangle that can be seen in the Argand diagram, and also by using some basic concept on all the angle related to the triangle and also the hypotenuse, the Pythagoras theorem. All right, okay, so this is how we solve this particular question from May, June 2012, okay, paper 3.3. Okay, so now we discuss the past year question for complex number taken from summer 2015 or May, June 2015 session, okay, then the paper 3.1. So question number 8, part number 1. Okay, so they give us a complex number W, and you can see that it is a fraction, all right, okay, with complex number on top and bottom. Okay, so without using a calculator, they want you to show that W equals to 2 plus 4i. Okay, so for this question, generally what we need to do is that we just expand everything for the W and then try to rephrase it become 2 plus 4i. So I'm having 22 plus 4i, and then I have 2 minus I squared. Okay, so for me, I will expand the square. Expand the square first, okay, it at the denominator. So numerator is still the same, 22 plus 4i. For the denominator, I will have 4. Okay, then minus 4i minus 1. Okay, so if I try to rephrase it nicely, this is what I have. Okay, so of course, to make it become 2 plus 4i, right, we cannot have this pattern and the fraction here. Therefore, we need to rationalize it. To rationalize a complex number, you need to multiply with 3 plus 4i. Then this one also 3 plus 4i. Okay, so you do the same thing again, you expand everything. Right, so 3 multiplied with 3, you get a 9. Then 4 multiplied with 4, you get a 16. Okay, 4 multiplied with negative 4, multiplied with negative 1, so you get 16. So for the values on top, you have 66 plus 88i, okay, plus 12i minus 16. Okay, simplify further, you have 500 plus, 50 plus 100i divided by 25. And of course, you can further simplify, become 2 plus 4i. And this is the answer that they want us to prove. Okay. All right, so this one is quite straightforward. You just expand, okay, the square, then you need to rationalize it, then eventually you can get the answer very easily. Okay, so let's have a look for part number 2. Okay, for part number 2, it is given that P is a real number. So again, highlight the word P is the real number. So real number means that it is just a number without the I. It is only purely a number only. Okay, such that you get this inequality. So find the set of possible values of P. Okay, so they give you an inequality, okay, an inequality, which is about the argument. All right, so first, what I want to do is like, because we already have the W in first part, right? Okay, so I will write it out as 2 plus 4i plus P. P is a real number. Okay, so P is a real number. Therefore, you don't need to change it become something with I. So P is purely only a real number. Okay, so I just keep it as P. And from here, right, what I want to do is like I will try to rephrase it become real part plus the imaginary part. Okay, so it is telling us that the argument for this complex number, right, the range will be from pi over 4 until 3 pi over 4. Okay, so that means how we actually find out the argument for a complex number. Let's say I want to find out the argument of a complex number 2 plus 2i. So generally what we do is that we take tangent inverse the imaginary part divided by the real part, correct or not? So for this part also the same. If you want to find the argument for this value, generally we also need to take the tangent inverse. Okay, so I'll change it become tangent inverse 4 divided by 2 plus p, which is between 3 pi over 4 and also pi over 4. All right. Okay, then next one. How can I continue further and find the value of 4 over 2 plus p? Okay. All right. So here maybe you need help, a little bit of help from a basic type, the basic graph for a tangent. Okay, so let's say this is pi over 2 and my tangent graph is from here to this part. I'm sorry. Okay, so my tangent graph will be from here to here. Okay, and also this one is my 3 pi over 2, right? My another part of the graph will be from here to here and then go up. Okay, so now if let's say they are saying that our angle should be from pi over 4 to 3 pi over 4. So for information, pi over 4 will be somewhere here. oh sorry, pi over 4 should be on the x-axis, sorry, pi over 4 should be on the x-axis, therefore it should be maybe somewhere here, pi over 4. Okay, then this particular point is pi. Okay, so 3 pi over 4 will be somewhere here. Okay, so you can see that for pi over 4, right? If you try to take tangent pi over 4, you get the value 1. If you get the value for tangent 3 pi over 4, then you get the value -1. Okay, so this is the graph for tangent. Okay, all right. So when you put in pi over 4 into the tangent, right, you'll get 1. When you put 3 pi over 4 into the tangent, then you'll get -1. So which means generally it's like this one. The next step that you have is tangent pi over 4 tangent 3 pi over 4. Okay, if you try to solve this one without using a graph, right, then your inequality will be something like this. Okay, which is very not logical because your larger number, your smaller number should be on the left. The 1 is the larger number, should be on the right. But if you write it out like this straight away, by just pressing the calculator, it looks like very not logic. Okay, therefore, after this step, right, you need to actually refer to the graph. Okay, and they want you to find out the value between tangent pi over 4 until tangent 3 pi over 4. So you can see that the tangent pi over 4 until tangent 3 pi over 4, right? It is between -1 until 1. Okay, so when you write out, you should write -1 until 1. Although tangent pi over 4 gives you the value of 1. Okay, although tangent 3 pi over 4 gives you the value for -1. But you want to write it in the inequality form, right? From the graph, you can see that the range is from -1 until 1. Therefore, you should write in the proper way, which is from -1 until 1. Okay? Then, after that, I want to make the whole thing upside down. Okay? So when you want to make the whole thing upside down also, the value is still the same, which is from -1 until 1. Alright, although you need to change the sign or whatsoever, right? But the range is still there, which is from -1 until 1. Then continue from here. You can slowly to get the value for P. Alright, then P is actually between 2 and -6. So this is actually the answer that we have. Okay, but of course, in all the parts here, right, I skip a few small steps. Okay, I skip a few small steps, but eventually you should be able to get the 2 plus p divided by 4 should be between -1 until 1. So always bear in mind that when you want to put any inequality, the smaller value should be on the left and the larger value should be on the right, so that it is bounded between this smaller and the larger value. Okay, all right. So this is how we actually solve part number 2 for this question. Okay, then now maybe you can proceed to part number 3. Okay, so for part number 3, let me scroll down. Okay, so this is what we have for part number 3. Okay, so now they tell us that the complex conjugate of the W is denoted by W star. Okay, so again, just to recall back, what is the W actually for us? So our W is 2 plus 4i. Therefore, the W conjugate will be 2 minus 4i. Okay, then the complex number W and W star are represented in an Argand diagram by S and T respectively. Okay, so they draw the W and W star in the Argand diagram and they are S and T. Okay, so find in the form of this one. So from here, you know that this is actually a circle locus equation. Okay, the locus equation for a circle. The equation of the circle passing through S, T, and the origin. Okay, so first we need to know where is the W and where is the W conjugate. All right, so let's say I'm having a 1 here, then 2, Okay, so maybe I'm having 1, 2, 3, 4. Okay, I try to plot, okay, the point W and also W star. So 2, 4 will be somewhere here. Okay, and then 2, -4 will be somewhere here. They are conjugate to each other. All right, so maybe for me, I will label this as S star, which is the W. Okay, then this is T, which is actually the W star. Okay, so here they actually tells you that the circle pass through S, T, and the origin. Okay, if the circle pass through ST and the origin, right? So it means that the circle might look something like this. Okay, so pass through S, T, and the origin. Okay, my circle is not circle enough, but it will look something roughly something like this. Okay, so pass through S, pass through T, and pass through the origin here. And by using this Argand diagram, right, they actually want you to find out for the final answer where the equation of locus for a circle, for this circle. All right, so you need to show them what is the center and what is the radius. Okay, so now for this kind of question, right? First they give you W and W star. Okay, I think we might need to use it. Okay, so let's say W and W star, if I draw the line, right, it will be actually a chord to the circle. Okay, this is a chord to the circle. And then when we are having a chord to the circle, right, it means that the center and also the center, let's say I don't know where's the center yet, but from here, because the S and T, they are conjugate to each other. So when you form the line, right, there's a property of the circle telling us that the center of the circle, okay, can be a perpendicular bisector for the chord. Okay, so when these 2 points are on the circumference, the center of the circle can be the perpendicular bisector for the chord. Okay, can form a perpendicular bisector for the chord. So that means the center should be somewhere here. So that when I'm having the center, okay, it can actually form the 90-degree, the perpendicular bisector for these 2 points, S and T. Okay, all right. So you can see that the center must be on the x-axis. Okay, so what is the value for this center? You can rename it as A and also 0 or x0 also can. All right, because it lies on the x-axis, right? Therefore, the coordinate should be A and 0. Okay, so now they want us to find the A, which is the center, then the K will be actually the radius. So to find all this, right, we need to use the help from here, okay, to let us form an equation. Then from there only you can continue to calculate. Okay, so first of all, we already know that the center lies on the x-axis, which is A and 0, so that it can form a perpendicular bisector. Okay, it can form a line, okay, that will bisect the point S and T. So that's the first thing now. Okay, then secondly, after you know that the center is here, okay, so you should know 0, 0 is on the circumference of the circle also, right? So that means this is actually the radius. Correct or not? And then if I look at the center with any point, either the S or the T, this is also the radius. So that means what? That means center I label it as C. Okay? So you can know that the center, the distance from center to O is actually equals to the distance from center to S. If you want to use from center to T also can. Okay, because very obvious also, you can see that the center to T, it also form a radius. All right, so you can use any two distance, CO, CS, or CO, CT, up to you. Okay, so how to find the distance of CO? Okay, so it will be x minus x squared plus y minus y squared. So you're having square root a squared for this part. For the right hand side, distance of CS. So for CS, it will be x minus w is 2 plus 4i, right? So s minus s squared plus y minus y squared. Okay, so from this part, what will you get? You can try to expand it. You have a squared minus 4a plus 4, then plus 16. Okay, and if you continue from here, you have a squared equals to square root a squared minus 4a plus 20. Okay, so if I try to simplify all this, right, I will take away the square root. Okay, then from here, very easily, you will get a equals to 20. And after that, your a is equals to 5. Okay, so from here, you know that this value is actually a 5. 50, the center. So the center is 50. And what is the radius? So you can see that the radius is also 5 units because from C to origin is the radius. So R, which is also equals to A, which is also equals to 5. So from here, you already know that the center is 50, and then the radius is also equals to 5 units. Therefore, the equation of the circle will be z minus 5 equals to 5. Or you can make it like this first. You can make it as z minus the center is 5 plus 0i equals to 5. The radius you can straight away put in here. Then eventually you will get x minus 5 equals to 5. All right. So we can see that for this particular question, generally we are looking at the property of a circle. Okay. So what is the property that we are using here? It means that when you're having a chord in the circle, okay, so the center can bisect the chord. All right, can be a perpendicular bisector. Okay, so from this point, you know that, oh, okay, the center must be on the x-axis. Then from here, you use some concept about the distance, because all these are radius, right? Okay, so radius equals to radius, continue, then you can get the value for A very easily. Then from there, you can conclude that the radius is also the same, which is 5 units. So this is the final answer for this part.